So, welcome to the Math Foundations Refresher. We are going to go through three sections. I'm going to talk about a few resources that you've seen them, but just kind of again reviewing. Say a few notes about CCRS levels and standards and sharing more resources around that. But we are going to spend the bulk of our time on the shifts and practices. So there will be this will be more of me sharing some resources, but then the shifts and practices will be pretty interactive. So please feel free to unmute with questions at any time or put in the chat, either way. So the CCRS Blue Book, this one, I like to just point out the difference between the CCRS Blue Book and the content progressions document. So the Blue Book is grouped by level, and oh, says my internet connection's unstable. Hopefully it changes. Okay, so grouped by level. So if we see this example, like all the level A standards and then the domains are listed here for level A. And so each domain is listed under level A before we get to level B, etc. The content progressions document is useful because it groups the standards by topics and domains. So this one is nice to kind of see how standards in different grade levels and CCRS levels, how they build on one another within the same topic and similar domains. So I love using this document to kind of just see like, what's a potential progression of understanding and content that I could teach. So this same standards just reorganized by topic and domain. There are also bolded standards and italicized standards. Anybody remember what the bolded standards mean in the chat, or you can unmute. It's okay if you don't. You can say no. Why some are bolded in this document and some are italicized. The bolded ones are models, so they're major works of the level. And these standards have been identified as those major works of each level. And so it's, I feel like it's an effort to help us focus our instruction. So like, if I have to choose what to focus on, because I have limited time and I have, varying students, etc. I can't teach everything to everyone and people are in and out. If I have to choose, one of the ways that I can help myself make a choice is looking for models, major works of the level, the bolded standards in the content progressions document. The italicized standards are called supporting standards. They're important. We can certainly teach them. They're just identified as supporting. So one of the ways to help me focus my teaching, models. The other thing though to then keep in mind is like, who's in front of me? Who are my students? What goals do they have? Because some of the supporting standards might be what I need to focus on depending on who's in front of me. So it's kind of like two different ways, two different filters for figuring out how do I spend my instructional time. Those two ways, like who's in front of me, what are their goals, and is it a model? Those are two things we can ask ourselves when we're trying to figure out what to focus on. And then for a collection of all the terms and definitions for them that we see, there's this document. And I'm going to put links to all three of these in the chat in just one moment. On the third page, there are all the terms for math. So this is actually the coherence is something that I was highlighting with what I pointed out about these two documents. There's coherence within a level, among domains, between domains, multiplication and area kind of, they go together, they relate to each other, okay, within a same level. But then you have coherence across levels, which the content progressions document can help me see. What are connections between levels versus what are connections within a level? And so coherence in both ways, that's one of the major shifts. So those two documents can help us decide how we're going to make connections for our students or help them. So those are three foundational documents that I'm going to now put in the chat that I wanted to quick remind us of. Any questions about these documents? Okay, just looking at the chat. Two more resources before we get into the shifts and practices. So talking about the levels and the making sense of standards. This is a document that was not in the course, but I find really helpful. I received this resource when I was part of Adult Numeracy Instruction 2.0, a national cohort. I was a part of a pilot this past year, and this was a document that they gave, and I'm going to put this in the chat now, to help color code the different strands, I'll call them, numbers, algebra, geometry, statistics, and probability. So it's color coded and it's grouped by levels, but it just kind of helps see, and I'll project it here, just kind of helps see where these different strands are coming up or areas are coming up in the different levels. What are critical concepts? What are fluencies that I want to work on with my students? Supporting concepts of the level, and just kind of seeing it organized in a different way without all the standard notation and numbers and whatnot. So yeah, just another resource. You don't have to use it, but I wanted to share it in case you find this helpful. The last resource is this making sense of a standard document. And you did this, you completed an activity with a similar worksheet. It's not the exact same, but similar worksheet in the foundations course, where you were breaking down 3.0A7, I think it was, about multiplication and division and the strategies and relationship between multiplication and division, understanding that relationship using strategies like properties of operations. And then there was a second part of that said, like, know your multiplication facts by memory or something. So both of those pieces, understanding the relationship and then just knowing your facts, were in the same standard. And so it could take me 3 days, a week, a month, depending on how often I'm with my students, to just teach one standard, because there are different pieces to it, different levels of comfortability, and different varying times and what students need to be able to master that. But this is a resource to help break down, like, what are the different chunks in this standard? And I just to help me think, like, how am I going to teach this? How am I going to make connections between the different parts of the standard, etc. So writing down the standard, writing it in our own words. What is this saying? Sometimes I have to look up some of the terms or whatnot in the standards, especially for the higher level levels D and E. Sometimes I'm like, what are they talking about? So writing it in my own words. Can I break this into chunks? What content are students expected to know coming into this standard? How are they expected to demonstrate understanding of this section? Do they need to be drawing? Do they need to be creating a graph? Like, what is spelled out in this standard? What are some teacher objectives? What are learning targets that then I can write based on those objectives, so that I can maybe put those in up in the room or on the screen if I'm teaching remotely. I can blank. I can multiply number facts 0 through 9. I can, something that is very student-friendly language. And then the other questions from that same assignment that I put on here from the foundations course: what special strategies or tools or are students expected to use based on what's written? So a similar question as to what I was talking about earlier. What are two strategies or examples? Two examples of strategies that I could use. Sometimes it's spelled out in the standard. Sometimes I'm thinking of it on my own, or asking colleagues. And this last question I really think is important. Like if I am identifying different parts for those long standards, what relationships between those parts are there? And so for the one in the foundations course, there's this understanding of relationships using strategies of multiplication and division. And then there's just knowing your multiplication facts, which sounds just like memory, right? So how do those go together? Some comments in the assignments have said that I just love this is, well, if I'm studying these relationships and patterns and properties of operations, then that's going to actually help me memorize my facts, right? Like I don't have to just memorize them cold. I can apply relationships and strategies that I've been thinking about and working with to then help me remember those facts. So just kind of thinking like, how do these fit together? So this worksheet is, again, just the last resource that I wanted to share in this refresher that may or may not be useful for you as you are planning your lessons, whether it's one-on-one or whether it is in a classroom setting. Okay, so I just talked for a while. Any questions at all before we move into the part where we are I'm gonna ask you to put lots of stuff in the chat. Okay, and Angelina, I hope I said your name correctly. Welcome. I
was on the audio, but now I'm on the computer. Thank you so much.
Awesome, awesome, good. Welcome. I just saw, because I have so many screens. I'm like, oh, we have another person. Okay, so here we go. In the chat, what are the 3 math shifts? And if you don't know, it's okay. But what do you remember? What are the 3 math shifts? Focus. Yep. Yep. Rigor. Last one starts with a C. Coherence. So we have focus, rigor, and coherence. And so if we look at the instructional shifts here they are, what you put in the chat. And then rigor has these 3 different parts that the standards outline in the blue book, like they're all supposed to be taught with equal intensity, right? So I have to make sure I'm balancing the conceptual understanding of a topic with giving students a chance to develop that procedural skill and fluency and work with applications, applying math knowledge, applying it to real world situation, applying one math structure or property or generalization to another problem, being able to apply it. So rigor is a more, there's a lot to rigor, but it's actually my favorite standard because of the conceptual understanding and application piece. Those were pieces that were missing for the most part from my own math education. And I think that it's, I think a lot of focus can be on the procedural skill and fluency, but adding in those other pieces can really make math come to life and help students own it so they can apply it elsewhere. So we're gonna look at some quotes from teachers. And so we can think about the shifts as like, this is my teacher lens. This is how I'm gonna think about planning my lessons. I can use that content progressions document to think, for my students at the level that my students are at, what are the major works of the level? What are the models? And that maybe can help me start to zero in on like, what am I going to teach? Because I can't teach everything. And then also thinking about, you know, my students' goals. That coherence, we can use both the blue book and the content progressions document to think about how am I making connections between other math topics or other levels, and then rigor. So this is really teacher focused. This is my lens as a teacher. And these are some quotes. So in the chat, I would like you to read this quote, and I can read it out loud as well, but read the quote and then decide what shift are they talking about. And for some of these, I will say you could probably argue a couple different shifts, but just think, what shift are they talking about? Focus, coherence, making connections within and across levels, or rigor with all three of those parts. What do you think for this first quote? One part is not more important than the other, and every lesson does not need to include all three. What do we think they're talking about? This one? Focus, coherence, or rigor? Good, I love it. I love that you did it and put a question mark. Like, I love it. So yes, rigor. The conceptual understanding, the procedural skill and fluency, and application. Equal intensity. One is not more important than the other. And I don't have to always teach all three every single lesson, but I need to make sure I have a balance. Okay, what about this one? From a daily classroom perspective, it means it's okay and even encouraged to delve deeper, especially when students make connections, ask questions, or want to share different ways to solve problems, like with coherence. Give the lesson some breathing room. Focus, coherence, or rigor? What one do we think? When I look at this, I'm like, oh, delve deeper. That makes me think of focus, going deeper. And then also, it does mention connections, which makes me think like coherence. But then because they said like with coherence, they are trying to describe focus. But there are actually a few different keywords in here that can make it seem like they're describing many. But they overlap. So that's just going to happen. All right, here's another one. What do we think? Focus, coherence, or rigor? In my instruction, I work to help students see what mathematical properties they already know and link them to newer concepts that they think they don't know. Yeah, coherence. Yep, linking different levels, different knowledge, making those connections. Okay, awesome. What about this one? I love the idea of this shift because it gives me permission to not cover everything. Yes, focus. And it can eliminate pressure. Sometimes it creates pressure for me because I'm like, but what ones do I teach, right? Like it's a struggle to be able to narrow it down, but it gives us permission. The standards are giving us permission, like let's focus and help students own some knowledge that then they can apply elsewhere. Okay, let's just do a couple more. What about this one? To be successful in math, we need to build a solid Jenga tower. The more concepts that are missing, things we don't know, the harder it is to succeed. If there's too many holes, we will fail and all will come tumbling down. Yeah, coherence, making those connections. Okay, last one. Almost all of our preparation materials that are used in ABE, and this was a few years ago, but I think it can still hold true, focus on how we do something, not why we do it. This is my major issue with some popular distance learning options. There are no explanations as to why. So when I'm thinking about this shift, it is delving deeper into the mathematical properties that allow us to do an activity, not just doing it. The why behind it. And this one has to do with conceptual understanding. This is what I'm gathering from this quote, is like, they're really talking about like, let's give the why behind what we're doing, not just the thing. So yeah, rigor, exactly. Having that understanding of what's going on. There are a couple more here that I'm gonna just click through. This one, moving between different representations of a function, graph, coordinates, table, equations, words, context. This is another one describing rigor, like multiple representations, really making connections about the why this is, and giving some fluency. This one, preventing topics from being isolated incidents, which is again, a lot of how I was taught. You know, fractions are over here and decimals are over here. And there wasn't enough connection from the beginning about like, oh, they're saying the same thing, just in different ways. And so that one is coherence, right? Let's constantly, as much as we can, let's make connections. And there are a few more here that I'll let you read. So it was nice to get some quotes from teachers, like, how are you thinking about focus or coherence or rigor, and just different ways of describing it. I didn't realize I had one more. Okay, yeah, wow, we had like 12 quotes. I thought I was further ahead. So you will get this slide deck, so I'll let you look at that. I'm curious if anyone is willing to unmute, if you're able to, and share what you find is the difference between the shifts that we just talked about, focus, coherence, rigor, and the math practices, because that's another big part of the standards that we're going to talk about right now. The shifts and the math practices. What is the big difference between those? And there may be more than one, so there could be multiple right answers, but what is the difference? Anyone willing to unmute? Rebecca, did you want to share?
Well, I was thinking that the shifts were more of how we teach it. Tells us how to teach it, but I'm not sure math practices, like how that's different.
Yes. Okay. Yes, there are probably many answers to this question, but something that I am thinking about calling attention to is the fact that the shifts are very much how we teach it as teachers. This is our lens. And so then there's something different about the practices, where the practices are more student behaviors. What am I wanting to see my students doing in the math class? How am I helping students develop these so that eventually they're able to model these on their own, right? Without me walking them through step by step. So for instance, one of them is using appropriate tools strategically. I don't want to always provide the tool to my students. I will in the beginning to show them how it works, whether it's a graph or a calculator or a ruler or whatnot. But then there will be times where I want to have tasks or assignments or something where students have to decide what is going to help me solve this problem. And maybe it makes sense to grab a calculator. Maybe it makes sense to grab measuring tape, or maybe it's I need to grab some graphing paper so that I can graph this out or make a table. So, you know, over time, helping empower them to demonstrate these on their own if they're not already. So making sense of problems, persevering in solving them, reasoning abstractly and quantitatively, being able to go from context to decontextualize math, contextualize to decontextualize math, the algebra, and then, but what is it saying in this story problem? How is this algebraic equation actually matched with this story problem? Or how are these numbers that I'm using, what do they mean in context? So being able to go back and forth, constructing viable arguments and critiquing the reasoning of others. This was a huge one that was talked about in the foundations course with which one doesn't belong, and being able to look at a choice of 4 and say, this one is different than the other 3 because, and developing that argument, being able to hear others' arguments and saying, oh yeah, okay, I see what you're saying, or I disagree. What did you think about this? So being able to engage in that conversation, modeling with mathematics, using appropriate tools strategically, we talked about attending to precision, looking for and making use of structure, looking for and expressing regularity and repeated reasoning. So being able to look at the specifics of what's going on, the structure, and then making sense of that, and kind of going from in to out, and then looking for and expressing regularity and repeated reasoning that is making those generalizations. So I'm looking, so the in to out, I just combined 7 and 8. Looking for and making use of structure, I'm really paying attention to a lot of the details of how either numbers are constructed or what I am, or equations and the distributive property, and looking at the structure of how you do this. And then I want to be able to then make generalizations and then apply that. And that's practice 8. So these have been grouped together into 4 categories. And so I know several people or all of you have gone through the foundations course. And so this is a question that many have answered about, well, okay, if these 2 practices, math practice 1, math practice 6, were put in this category, so these 2 were grouped together, that they are overarching habits of mind of a productive mathematical thinker. To yourself, I want you to think, why do you think these are grouped together? Or if you answered this online in the foundations course, think, what did I say? What connections did I see? Why would they maybe be grouped together? And I won't have a share, but I just want you to think on your own first. And then you can read this quote, read along. This is what someone else had to say. Overarching habits of mind of a productive mathematical thinker is a good term for this grouping of math practices because they provide such a broad foundational approach to thinking about math. The idea of understanding, planning, revising, and finally solving problems, combined with the precision and ability to express and explain one's thinking, lays the groundwork for everything that will follow. Any thoughts on that? Similar to what you were thinking? Different? Did you want to add anything? You can use the chat, you can unmute. Any part resonate with you? I love that. Jamie in the chat said, I hope I'm saying your name right, Jamie. I recall responding that it had a focus on the communication of math. And reading this quote makes me realize how I could have elaborated on what that communication is. Okay, Yeah, I love that communication, making sense, and then that attending to precision. Maybe I'm reading between the lines, but like being able to then communicate to others what I'm finding, there's precision that is needed. And even in the planning phase. So yeah, I love it. Okay, here's the second grouping, reasoning and explaining. Math practice 2 and 3 were put together. So math practice 2 is reasoning abstractly and quantitatively. And then math practice 3 is constructing viable arguments and critiquing the reasoning of others. So again, to yourself, think, why would these be grouped together? And then I'll show a quote in just a moment. All right. Here's a quote from the course that someone wrote. The common skills between MP2 and MP3 have to do with understanding the meanings of quantities and being able to see a problem solution in more than one way. The process of assigning meanings in MP2, specifically in remaining flexible with operations and their properties, is very similar to the requirement in MP3 of listening to arguments and understanding the difference between two different ideas. While MP3 states that the clarifying questions should be used to improve or find mistakes, it is also possible that those same questions will show that there is more than one method, which again helps with a deeper understanding of the problem. Any comments, reflections, questions about this one? I love this idea. I didn't think about this way, but I love this sentence right here. Assigning meanings in MP2, the process of doing that, remaining flexible with operations and their properties, reasoning abstractly and quantitatively, going back from decontextualizing to contextualizing, back and forth. It's very similar to the requirement in MP3 of listening to arguments and then understanding the difference between two different ideas. I love that. Being able to reason abstractly and quantitatively can then help me understand others' arguments. So I love that connection that this person made. All right, 2 more groups. Here's the third group. So math practice 4 and 5, modeling and using tools, model with mathematics, used appropriate tools strategically. This one, it's kind of in the name, but you can kind of think why might these be grouped together? And why did this? Yeah, what's similar about these, that they were put in the same category and they're both in the title. Here's a quote from someone. Practice 4 and 5 have been grouped together because they're both focused on using what we already know and have experienced in the real world to solve problems. Practice 4 asks us to recognize math in everyday life and create models that will help us determine if we are answering questions correctly. Part of creating models that work is determined by which tool is best to use in that situation. So these practices really do go hand in hand. Any comments, questions, phrases that resonate with you or that you like? Or other comments about why they're grouped together? Yes, Jamie, I love that. I would love to know how to encourage students to use other tools before they try to immediately jump to utilizing their calculators. We're going to talk through a couple of exercises, and I'm stumbling because I'm thinking, okay, do they exactly relate? But I think they do relate to your question. We're going to get to that last section in a moment, talking about some sample activities, and then where are the shifts and practices in those activities. But they might use their calculator for parts of the exercises. However, there's thinking that's going on. So it's almost like they have to, in the exercises I'm going to show you, they would have to interpret their answers to be able to really complete the task instead of just relying on their calculator. So yeah, I love that. And I know that you're in the cohort. So we're going to kind of think, we're going to have fun thinking about that as we are going through different activities in the cohort as well, because I think that that's a common issue is like, yes, the calculator is a tool. You're not always going to have to calculate numbers in your head in real life. You have your phone, you have whatever, but then we want to make sure students are understanding the thinking behind it and what procedures do they need to know without the calculator, etc. So yeah, definitely a balance. I love that comment. Okay, last group, scene structure and generalizing, math practice 7 and math practice 8. That looking for and making use of structure, and then looking for and expressing regularity in repeated reasoning. And so why do you think these were grouped together? And here is a quote. In MP7, we are looking at breaking down larger ideas into smaller pieces that we either already understand or are easier to grasp. However, in MP8, we're starting with the smaller pieces and using identified patterns, many smaller pieces coming together in a predictable way to create an understanding of the larger pieces. They're really the same thing, but being done in opposite directions. And I have to confess, when I described that earlier on the previous slide that we had about 7 and 8 and using the details and then making generalizations, like I have always confused math practice 7 and 8. They're just so similar to me and their descriptions and whatnot. I'm always like, oh, which one is that? So it was responses like this, and there were more than one in the cohort or in the foundations course online. Responses that like this that really helped me understand, like, that's the difference, right? So yes, thank you, Angelina. So an example would be something like seeing, looking at, I'm not even going to fumble right now. I was going to say, and then I didn't think it through completely, but I know there's an example here. But like looking at multiplication. And so I could look at patterns and structures of like multiplying by 5. Yeah, here we go. So like multiplying by 5, I could see patterns and structures. I could look and see that they're always ending in 0s and 5s. Like, so I could make that noticing, like if I'm just multiplying by 5 and then I'm seeing, okay, these answers are always ending in 0s and 5s. And of the problems that I'm working on. But then I could say, well, if this is what's happening, is that always the case? right? And we're going to look at like, is there a generalization I could make? And so any number times 5 will always end in 0 or 5 or something. And there is an activity we're going to talk about in a moment called always, sometimes, never. And doing that is actually helping with that, those two practices. And so because we are going to talk about that, I'm going to actually pause, and I'm going to go straight there because it is in context here. Thank you for letting me think on my feet here and be a little sporadic. Here we go. So always, sometimes, never. We'll jump to this. So Joaquin received a 5% raise. And so we're going to look at actually a few different examples. And then hopefully by the end, Angelina, will have answered your question. And if not, please let me know. So Joaquin received a 5% raise and I received a 10% raise. My raise is larger than Joaquin's. And so then I would ask, okay, is that always, sometimes, or never true? How do you know? So I'll give you a moment to think about that. Like, is that always, sometimes, or never true? So with this kind of example, I might give this to students to, it's just a statement, just like a factual, it looks like a factual statement, to then decide, is this always, sometimes, never true? And so we, would be working on percents and maybe wanting to see, like, what are some misconceptions that students might have about percents, or misunderstandings, or what's missing. So maybe this is used as like a formative assessment, an open-ended formative assessment. So 5% raise, 10% raise, it looks like 10% is bigger. So yes, it makes sense that my raise was larger. However, what we want to see if students are able to do is say, well, no, actually that's sometimes true, right? So like 5% of what? 10% of what? And so this would be a way of being able to look at the structure and the details of 5% of a number. What does that mean? So 5% of 100, $5, 5% of 200, $10, 5% of 300, $15, etc. And then 10%. Well, what is 10%? So like, if I have 10% of $400 versus 5% of 50,000, it's not always going to hold true that the higher percentage is the bigger number. I have to be talking about the same whole. And so then from doing that, looking at the pattern of numbers, when I take 5% of a number or 10% of a number, if it's not the same number versus if it is the same number, what's happening, looking at that structure, math practice 7, then being able to make generalizations about, okay, if I am talking about the same whole, 10% of a number is always bigger than 5%. However, if I'm not talking about the same whole, 10% of a number is not always bigger than 5% of a number. And that's true. Those two statements are true all the time, regardless of the number, which would be more generalizing of the patterns and structure that I noticed. I hope that makes sense. If not, or if someone else can explain it better, please unmute and share. So interrupt me if you want to unmute and say something. These are just some sentence frames that you could use with students to kind of have that conversation. And so you can ignore the respond to someone in the chat, because I didn't have us actually do this one, but whether students are in real time doing this, or if we're in a one-room schoolhouse and students see someone's argument, and from a previous day or something that you made up, and then they're responding to that. It doesn't have to be real-time conversation. I just said real time twice. It doesn't have to be a conversation in real time. It could be you provide student work or sample student work for students to then comment on and be able to say, I agree with because, I disagree with because, or write down questions. I'm confused about this. I would like them to explain this further if they're not being able to talk to each other in real time, but then conversing. So with an activity like this, and here are some other examples of statements for students to be like, is this always, sometimes, or never true? We talked about math practice 7 and 8, that is being used here, looking at structure, making generalizations. Any shifts or practices, other practices, do you see potentially being in an activity like that if you did this with your students? Always, sometimes, never true. Multiplying two numbers together results in a larger number. Sometimes, if we're multiplying by something less than 1, then that changes it. It could be, talking about shapes. A triangle is a parallelogram. Always, sometimes, never true. And so students have to wrestle with that, and they have to explain why. So thinking about, okay, definitely math practice 7 and 8. Maybe math practice 3. Constructing viable arguments and critiquing the reasoning of others. For sure, constructing viable arguments, because they have to make their own argument and explain why. And then if we provide them an opportunity to critique someone else's, whether it's in real time or on paper. Any other practices from the list or shifts you see that could kind of pop up in an activity like that? And there are many right answers, just seeing what you notice. I think it has the potential to really highlight conceptual understanding, or if people have misconceptions, to do something like that. So rigor could be addressed there. And I think you could make a case for a lot of these actually. Attending to precision could be there. Making sense of problems and persevering and solving them could be there. Making connections between different representations of numbers, depending on what the statement is that people are responding to. There could be connections there, right? Like there's a lot of opportunities for students to be really diving into practices and shifts and the standards with even just putting up a statement and saying, is this always, sometimes, or never true? I am going to go to, we have about 9 minutes left. We have a 2-minute countdown. So I just want to show a few other activity ideas. And the same question is like, what shifts do you see? What practices do you see? Or what do you see the potential for? So here's another example. Have people heard of or done open middle problems? If you could put yes, no in the chat. Just curious how familiar people are. No, okay. Thank you. No. Oh, okay. So this excites me only because I love these and I love sharing them with people. So, okay, I am gonna I'll put links to all of these resources in the chat in just a moment. So open middle. Here is an example of an open middle problem. I'll give you a moment to look at it And if your screen is small, the directions say make 4 points using the integers -4 to 4 at most 1 time each, so that each point is in a different quadrant. And then there's space for 4 different points. There's numbers down here. And I made screenshots of these, but these are actually Google Slides that you can download for free, and these are movable. So students could do this for digital literacy practice as well as thinking through a math problem. But it's called open middle because there is a right answer, and there could be more than one answer, but like the way that students arrive at it, at the answer, can be different depending on the student. And so there's like an open middle to it. Like how we get there might look different student to student, and student strategies on like, how are you going to think through that? So this could be after students have been exposed to the coordinate plane and kind of, learned about plotting points and are comfortable with the 4 coordinates. This could be a way of giving them an opportunity to arrive at the answer any way they want to, but can you give me an example of a point that's in each, in a different quadrant, 1 for each. And so I like that there's just a little bit of different thinking behind it. It's not closed. Here's another example, area of a quadrilateral on a coordinate plane. So using the digits 0 to 9, at most 1 time each, fill in the blanks to create a quadrilateral with an area of 16 square units. So not all of our students are going to be at this level, but for someone who's going to take a high school equivalency test, this is a problem that if you can work your way through this problem, even if it takes you 6 attempts or more to do it, it's going to help you because there are some problems on those tests that have you work with figures on a coordinate plane and thinking about area or where would this point be, etc. And so having a problem like this can really open it up. Students can arrive at the answer any way they want to, as long as they use these numbers at most 1 time each and create coordinates with an area of 16 square units for a quadrilateral. And students can check their answers, right? You could then give them graph paper and they could be like, did I do it, right? And if not, how could I adjust? What do I need to adjust? And here's another one. I'm going to go through this one more quickly with box plots. And, this is another way, a different way of seeing what students remember about box plots with having to use these numbers at most 1 time each, or the quadratic formula. What numbers would I put in here to get the least value, or what would I put there to get the greatest value? And so thinking through, do I want the 9 on the top or on the bottom? Well, how is that going to change my answer? Is it going to get bigger if it's on the top, or is it going to get smaller if it's on the top? Or maybe I need the 9 in the square root because I need to plus or minus a bigger number or something, right? Like kind of thinking through, if I place this number here, how is that going to change the answer? So there's, again, an open middle, but there is a right answer. So it can be more of a closed end. So with something like that, what shifts and practices do you think students would be, what practices do you think students would be engaging in? And what shifts do you think might be part of that kind of activity? Does anybody think shift 1, making sense of problems, persevering in solving them, would show up in a problem like this? Would students have to do that? Yeah, I think so. And I think students would also need to look for and make use of structure. You could probably make a case for all of them, but looking for it and making use of structure, that example of like, where should a larger number go versus a smaller number if I'm trying to get the greatest value? Or where should they go if I'm trying to get the least value? Like, that's a structure thing. Like if I'm multiplying something by 9 or -9, or if I'm, because yeah, then you throw in the negative and then that just changes things, right? Like if a number is going to be big or small. So the structure of numbers and what's going to happen when I do the opposite of it, what's going to happen when I divide by a number that size, etc. Right? That's getting into structure. So there are some conversations to be had there. That is the last one that I'll show you. I want to show you the website before we go back to the large room. We have 2 minutes left. You don't have to go back yet. I just want to show you this website where you can get the resources. You don't have to create them, and they're for every level. So I showed you some mid to higher level problems, but it actually goes down to kindergarten grade. So here on this openmiddle.com is Get Google Slides version, because there are printouts as well. You could have paper, but if I were to click on like 2nd grade, I get to make a copy of the whole PowerPoint, and then there are the standards on each question. They let me know what standard it's targeting, or standards, and these are movable numbers. So if you did want to have students do this electronically, you could. But there are, how do I get 39? How do I, what numbers am I going to add in? What's then the sum, etc. So different levels of complexity and different CCRS levels available here. The other thing, I hope I have time, I have 47 seconds, is where to go. What I love about this is there is a printout, and you could make a, there's a Google Doc version as well, but it literally has first attempt. What did you do? What did you learn? How's your strategy going to change? Your second attempt. What did you do? What did you learn? How's your strategy going to change? And it goes all the way up to 6 to just to send the message. It's okay to have to adjust your answer, but we can still think strategically about how to do that. So I love that message that it sends. And in the slides, you will have access to 2 more resources, activities, I mean, and that you can look at, but I just put some links in the chat for you